What is up, guys? It's Vasya here again, and today we will be solving the fourth problem of this year's IEEE Extreme 11 contest. The problem is called Preparing for Extreme 12, so let's do it, let's prepare for it. Alright, let's see what the problem has to offer. Well, let's see the input, it's easier that way. We have some number of books, okay? There can be at most 100 books, and each book has some topics. For example, the first book, each line represents one topic. The first book has the topics backtracking, dynamic programming, and greedy. The second book has dynamic programming, the third backtracking, and so on and so forth. Now, each book also has a time that it takes to read it. So the first book takes 300 minutes to read it, the second one 125, the third one 35, and so on. What we need to do is cover all topics in the minimum amount of time. So we need to find a subset of these books to read so that we cover all of the topics. The key thing here to notice is that each book will have up to 20 topics, and there will be at most 20 topics over all of the books. Now this already says something. To generate all subsets of 20 elements is 2 to the power of 20. So there are 2 to the power of 20 subsets, and 2 to the power is around 1 million. So we can do that, right? We can generate all subsets of topics. Now, there is also a small amount of books total, so we can simply iterate over all of the books from the first to the last, try all combinations of topics, see what minimum time we have already for those combinations, and try to add this book to those combinations. So basically we have an option: do we read this book or do we not read it, right? We have two options. If we do this recursively, it will time out, so we will use dynamic programming here. Okay. That's it. One more thing we need to notice is the memory limit is 128 megabytes, so we might have to optimize a little bit. We'll see about this later. Okay, let's get into coding. Now, as you notice here, there is no number n in the input, or number of topics, or number of books. So we will just need to be a bit creative with the input here. Let's see, read it line by line. Okay, so string line while get line, so in line. Now we have read the line. Now we need to parse the line. Each line has a time, right? And each line has some topics. So we need to know the number of books and the number of topics. Let's see, and books 0 initially, and topics 0 initially. Okay, we need to store the time, so int time of, there will be 100 books, and topics, so vector string topics. So each book will have its own vector of topics, its own array basically of topics. Let's parse it now. How do you parse a string and read all of the parts that it has? Well, the easiest way in C++ is string stream. So basically we will create an input string stream from line. Then we will read the time. So is, just like you read from standard input, time of books, and then books plus plus at the end. All right, now we need to read the topics. So while is line, no line, but we need to read a new string here, string topic string, topic string, topics of n books dot pushback what? Topic string. Right. Okay. Now we have read the topics and the books. We also need to map these strings to integers, so we need to know which topic is the first, the second, the third, and so on. Okay, how do we do that? Well, we will use a map for that. Map from a string to an integer called map function, for example, map func. Okay, and once we read it, we need to check if we already have it. So if map func dot find topic string is equal to map func dot end, meaning that we have not encountered this topic, so we simply add it. Func of topic string is equal to, the next topic is this, so end topics and end topics, sorry, end topics plus plus. Now we have mapped the strings to integers. So why do we do this? So that we can easily map them later to bitmasks, and we will use bitmask in our dynamic programming. So what do we need? We need a 2D array. The first index will be the book that we are currently at. So there will be 100 books, and there will be which combination of books are we currently looking at. So this will be, there can be at most 20 books, so 2 to the power of 20. Okay, so here we say we are currently at the ith book and looking at this combination of topics. So the second parameter will basically be some bitmask, let's say something like this. And what this means is that the second, third, and fifth book are covered by this bitmask. Okay. Now let's solve it. So we will initialize our DP array to infinity. How do we do that? Well, we can use a value of 62 here, and it will set all of these integers to large values, something around 1 or 2 billion. I'm not sure exactly, but really large values. So we don't need to worry about that. Size of DP, all right. Which is our first state? Well, our first state is when we haven't read any book and covered any topics, our score will be what? 0, right? It takes 0 time to read 0 books. 0, and empty mask, since we have not covered any topics, is equal to 0. Okay, now let's iterate over all of the books from 1 to n books. From 1, because we have already used the 0 state, so we need to use 1 here. Okay. Now, for that current book, we need to create its bitmask. Okay, so it has some topics from those topics of in the range from 1 to n. It covers some topics, let's say 1, 3, and 5. We need to create a bitmask for that. And book mask, let's call it a book mask, is equal to 0 initially. Now I iterate over all of its topics. Topics of I minus 1 here, dot size, j++, okay, we need to cast this to an integer. And book mask, now we do an OR, logical OR operation to set the bit, is equal to what? Let's see, topic string, first let's get the topic string out, is equal to topics of I minus 1 j, that is the actual topic, and here we will do this shift map func of, we don't need these brackets actually, okay, of topic string. Now this line here will convert the actual string to the number of the topic, to the index of the topic, and by shifting the number 1 to the left that many bits, we get what we want. Actually, it will be 2 to the power of something. Let's say this is the second book, so shifting 1 2 times we'll get 2 to the power of 2, okay, which is nothing more than something like this, okay. And if we want to add this to our book mask, we'll simply do an OR operation and it will set that bit to 1, okay. Now we have our book mask. Now we need to know all the previous best solutions that we have. So let's iterate over all masks. And say that dp of I is equal to dp of I minus 1 mask. Okay, we simply copy the old solutions, nothing more. Sorry, dp of I mask. Okay. Now we need to try to add this book to all of our masks. Again, I will iterate over all of the masks and try to add the new book. Okay, so this here says what happens if we don't take the book. The ith book, and this here we'll try to take the ith. If we take the ith book, so if we take the book, we have a new mask, right? Is equal to the old mask combined with the new mask, or combined with the book mask. Okay. Now we need to check whether this gives us a better solution. So if, what is the old solution? Well, the old solution is dp of I minus 1 with the old mask. That is the old solution we have, and by reading the ith book we spend how much time? Time of I minus 1, because our books are actually numerated from 0 to n books minus 1. That is why we need to put I minus 1 here. If this is a better solution than what we currently have here, I new mask, right, by reading this book. So this says up to now, without reading this book, plus the time it takes to read this book, if that is better than reading this book and combining it, right? The old mask plus the new mask gives us the combination of bits that we need. If it's better, then we simply store it. So dp of I new mask is equal to dp of I minus 1 mask plus time of I minus 1. Okay. That's it then. Now we simply need to print the result. So what is the result? Well, the result will be stored in the last book. So cout dp of n books, right? And how do we say all topics? Well, that is 2 to the power of n topics minus 1. This will actually be something like, let's say we have 7 topics. This will look like this. Okay, so this is the mask we are looking for, the result. Okay, and we are printing it. $200, and the result, let's see. Yes, it is $200 indeed. Now we have a problem. Let's see what the problem is. If we submit this solution, and I need to comment this line here because we are not reading from file. It compiles, but when we run the examples, we get memory limit exceeded, and that is because we are using too much memory here. But what we can notice is that, let's see where we are using dp. So here we are using dp, so we are only using the last values. When we are looking at I, we are using only value I minus 1. Here also, looking at I, using only value I minus 1, so only the previous value. We only need to store 2 values at each moment. We don't need all of them. Okay, so we can optimize for memory here. We can optimize by a factor of 50 actually, by changing the 100 to 2. Now we need to know previous state 0 in current state 1, and wherever we are using I, we put current state. Whenever we are using I minus 1, we put previous state. So previous, current, current, previous. At the end, we need to print what? Sorry, we had a bug here. We need to. Oh no, we don't have a bug. We need to. At the end, we need to swap these values. So previous becomes current, and current becomes previous. Okay, and in the end, we need to print the previous value, which will be our actual result. Okay, compiles. Okay. $100. That's it, guys. This was an interesting problem using dynamic programming. I hope you liked it. You liked the explanation. And I will be posting the link to the code in the description. Also, as I said, there will be a link to bit manipulation if you are interested to learn that. And that's it. Thank you. Have a nice day and see you next time. Bye bye now.